All right. Well, it's 9:30 or 9:40. It's usually the time that I take a break. But you all been waiting, so I'll get things moving along here. Now, for chapter four, as I said, that there was recorded modules that are kind of always there, but just check. I think that module was labeled for that subject matter. Yeah, so lecture four was heat and second law of thermodynamics. That's the lecture for chapter four, and I had mentioned that you could, since I had to be away, you could just look at that. I mean, it's the same, basically the same kind of lectures that we've done. It was just that one, the one for, I think that was actually last semester, maybe last spring. I can't remember. I usually replace them, but if I get one that's so good, I like to keep it forever. Um,
So we can go back and just take a look at that Zoom meeting then for that chapter?
yeah, it's
Okay.
basically the same as what we do, is just from the previous semester. And the reason I have them all in there is just some people like to work ahead. So, like with the COVID thing, because we started this in COVID, and even now, as you know, I'm kind of flexible. Technically, when you have a remote meeting, it's actually mandatory. But
Okay.
we got like 30 people in this class, and only eight of you show up, and I don't penalize people for that just because I got into the habit of doing that with COVID because, it's COVID. And even now, still, people have schedules, and I just try to work with people. So these lectures are actually the lectures. So you could, to get the information, technically, you don't even have to come to class because it's basically the same thing. So the short answer is yes, that is the lecture for chapter four from so you can just go back and take a look at that.
Okay.
Now, I was going to say, if you had done that and still had some questions, I can address a few things here. But if not, or if you haven't looked at it yet, maybe I can give you some time. But I think since it's there, we could just go on, to chapter five. That's what I had planned to do.
Mm.
Um, but it's I could say a few points, words about. I mean, I guess you've had didn't take a look at that yet. If you were asking me that question, is that right?
Right. Yeah, because I haven't looked at it yet, so I was just like, okay, we're going on even further. So, yeah. And I also had a question because I think approximately some of us, had a question about the lab. We had a hard time even uploading some of the content. Even I had trouble uploading even like the document itself, and I couldn't find any of the assignments on there. So it's a bit
Okay.
glitchy.
Yeah, me as well.
Okay. All right. Let's talk about that. I think I did see a few emails about that that I haven't been able to haven't addressed yet, but I will answer those as well. But let's take a look. So, yeah, maybe the best thing to do is to just share my screen and go through, because honestly, I think that the website did change a little bit, maybe based on. I mean, they kind of update this website every semester, so it might be a little bit different from some of the things accessing the workbench on the Beyond Labs. Uh, the Beyond, yeah, the for whatever it's called. Yeah, Beyond Labs, relative to previous semesters. So let's just take a look. So let me open up a couple things here that we can have access to. Class. All right, so us. Oh. Okay, first let's just go to the last page. All right, can everyone see my screen?
I can see it.
Okay, so I've got the labs set up. Thank you. So yeah, labs are set up here, and we can just. I presume you've looked at some of these. Oh no, this is our class.
Yeah.
Here you go. This is yeah. Okay, so this is the modules for physics 14, and like for example, the first lab is here. So the way this is set up is, of course, you just go and you go to the module, and I should have the what I want you to use as the worksheet just here. So if you open that and download it, that's the thing that you're going to fill out and turn in, and that is the um, also the procedure for that specific lab, whatever page it's on. So if it's graphing motion, then this is going to be the worksheet that I want you to use for graphing motion. You can download that to your device and then you can write on it, edit it, and do whatever. That's what a lot of students do as opposed to having a separate piece of paper that they can turn in. And so you can just fill this out. You'll follow the procedure here for the lab bench once you get the lab bench, up and running on virtually, and then just fill this out. Now I mention that because Beyond Labs they've made completely new worksheets on their website, and also they try to. Initially, it wasn't set up that you would have could set up a whole classroom on the website itself. And so it's just more cumbersome and confusing, as you say. And so when they set up the lab to do that, I just have never done that because I already had the lab set up within our modules and I already had the original worksheets. So basically, the only thing we need that website for is to access the lab bench. That's the first thing. And so this is where you're going to get your worksheets from. You just open that up in a different page and then go through and work the lab as you're getting the instructions from your downloaded worksheet here from your Canvas page. And then whenever you finish working out the lab and filling out the worksheet, you just upload this specific worksheet to the place where the, the connection or the space to upload it within this module as well. So I hope, yeah. So that's that for this worksheet in this module and how to access it from your Canvas module. Now, the difficult thing is, confusing thing is how to access the lab bench itself. So let's see if we can go and clear up some things about that.
Yeah, that's what I was confused about, how to access the lab.
This part that what we're about to do, what I'm about to show you.
Yes.
Yeah, okay. Yeah, I admit it's a bit confusing. So I've already opened up and I'm into Beyond Labs. So I'm assuming everybody was able to to register and get in and at least open up the website. Is that correct? Or are there any issues with the registration code or anything?
No, yeah, we was able to like get inside the Beyond.
Okay. All right. So this is the work page. It says instructor dashboard. So this is what you see. So there's one of the things that's a little bit confusing is there's two ways to access LabBench. Apparently, it opens up directly to the website where you can go over here. I'm not going to do that because our labs are not there. You can go over here and play around with all that stuff and try to find the labs. But for the physics, traditionally, at least for the physical science, you have to of the two options, web-based versus desktop, you need to go to the desktop. So you click this desktop and this page comes up. Now, the first time you come to this page, so on this page, it's basically it's installation and setup, but it's also continues to be the same page you come to even after you set it up. But there's two options. So when you first are setting up, you go to download and you download something called a Connect 3 or whatever. It's basically a software. Yeah, it says Beyond Labs Connect 3 right here. That's a software that downloads to your device. And so that from that point on, and then you have to open it, if particularly you have a PC, whatever your, however you open up a software to get on your device, you have to go through those processes. A little bit different for Apple versus PC, but it downloads a package, a software package to your desktop, and then you have to go through the procedures to open up and install it. And it'll be a little icon. Like maybe I could find it on mine. It's kind of hard to. Uh, I know where it is on my PC version on my Surface, but I've never really made the effort to find out where it would be installed on my Mac. But anyway, you press download, it downloads there, and then you go through the process. Now this is like a little ghost software that will be on your computer until you uninstall it. So what happens is from that point on, once you go to the website, you go through the same process that I just said. You go to this site, it probably automatically uploads to the web page, but then you click over to the desktop. And once you've installed it, then from that point on, you press connect every time. So I'm about to do that right now. I'm going to press connect. And then it asks, do you want to open up as a warning sign? So yes, open. And then it brings up basically these options here. These are all the options for the different types of labs. Now, for I have them all here because some physics labs are in the chemistry and stuff, physical science, physical chemistry and stuff. They're for other classes. But the only one that you really need is I generally have you do physics and physical science because we can sometimes get labs from both of this for this class. I think I might have it set up that way. So you open access to both physics and physical science. This is what I want you to do. Now, even with this, there's still some options. If you look down here, it'll say higher education versus high school or something like that. Let's see. It should highlight when I click on it. When I put the cursor there. Yeah. High school versus higher education. We want to go with I believe it's the higher education for all of them. But I'll check that now. Yeah, higher education. Let me make sure. So first of all, so I think the first lab we were saying there was what was it? Graphing constant motion. In fact, I think it actually is in both of them. But let me take a look here. I'm gonna go with. Oh yeah. So for physics, it's high school and higher education. For physical science, it's middle school and high school. Yeah, we'll definitely go with the high school. Sorry about that, but some of these labs are actually the same. They're just slightly different right up. So I'm going to click on this. So I guess you have to have it highlighted. The blue, if it's in blue, that means that that's what's highlighted. So since I've had that highlighted before, that's when, yeah. So in other words, you can toggle back and forth. Make sure that for physical science, the higher ones are always, so high school for physical science and higher education is highlighted for physics. But for now, let's just go to the physical science. Once that's highlighted, open it. Now, this is the lab bench. This is the place where you're going to have access to the actual labs that you do. Still some issue to talk about here, but let me just take a minute to make sure, see if you can catch up with that. Can everyone see that?
Yes.
Awesome. Following along. Okay, so here it's even a little bit more confusing. I'm sorry about this. But this is actually the best virtual lab that's out there. Better than Labster or any other thing, like by far. But still a little bit wonky with all this. But anyway, now you can access. So the workbench is the thing that I'm calling the lab, virtual lab space that you'll actually work in to conduct the lab. That's the language that they use, workbench. And Yes, Julia, question.
Oh, I was gonna say on my side, my screen is like frozen, so I can't tell what you're doing. I'm sorry.
Okay, that's
Yeah.
all right. Can you oh you mean your your screen is frozen so you
Yeah.
can't see that.
Try to leave and come back.
Yeah. Okay.
Yeah, sometimes that happens with maybe whenever I click the workbench. So that used to happen before. In fact, it used to not let me access the. Oh, I see. You can't see it. I'm looking at you now. Yeah, gotcha. It's doing the
Yeah,
same
cause
thing.
yeah, cause
Yeah.
your mouse like completely stopped moving, so I was just like, wait a minute.
Okay, thank you. I get what you're saying. Thank you for pointing that out. So
uh,
I'm gonna have to exit out and then come back to this page. So I'm doing that right now. Thank you for letting me know.
uh-huh.
Now, I'm gonna share again and then pick out that page. So whenever I click that button, it opened up this page. Okay. So does everyone have that page opened up so you can see it?
Yes.
Okay. Okay, and that, yeah, okay. So now the workbench can be accessed a couple different ways. All of these buttons up here, they are, and I'm not going to click one, but let's just say mechanics. When I open that, there's going to be several labs. Well, that, boy, actually, it's basically the physics lab setup. Well, it's not actually set up, but it's like the physics lab that has all the things you need for mechanics in it, for any mechanics lab. But it's not actually set up for you to do the lab. You'd have to manually set them up yourself. However, if you go down here to where it says high school worksheets, these are not actually worksheets. The worksheets are the things I've already uploaded to your Canvas page module specifically for the labs. But the reason that they label it this way is because once you go inside, these are also lab benches that you can open up as well. But they're lab benches that are already preset for the specific worksheet that it's labeled of by which it's labeled. So our first lab, for example, is I think graphing constant motion. So we have to go in here and open up the one defined graphing constant motion. I think it's going to be under forces and interactions. So let me just open up that scroll down menu. And sure enough, you see here, there's like 4 or 5 labs in there. One of them is graphing motion. That's the lab that you would use for that worksheet that we're doing. So when you open it up, I think once we're in it, we'll show it. It brings up the lab bench that's already set up for graphing constant motion. Actually, let me go back and make sure because there's two. There's one graphing motion. There's one graphing constant motion. One's supposed something the other. But you can still use one worksheet for the same. Yeah, that's our graphing motion. So this is graphing motion. So yeah, and that was the name of that lab bench that opened. So that okay, you can't see it. So here again. So just to remind you, this is our first lab. It's called graphing motion. This is the worksheet associated with it. And yes, this is how you would access that lab bench for graphing motion. So let me just kind of go back out of this. By the way, the way you can exit out of this lab is, I'm going to say a lot more about this in a minute, but just get, actually, I think you just have to close it down up here. Yeah, get back to the lab bench here. So again, we access that by having this on high school and then opening it and then accessing that. that- Sorry, I'm just trying to get back to this thing. Where is it? Nope. All right. So forces, interaction, graphing, motion. Now, and again, you can go through all these. I think lab two is balanced for, I mean, two and three, they're down there, but here, this is the lab one. So then you basically click on that and it should open up the lab bench. Oh yeah, Tamiko?
Yeah, so my fault for the background. I was able to get into the lab and everything else. My problem
Mhm.
was I didn't know how to actually do the things that were on the for the procedures because some of the stuff it wouldn't let me click or it wouldn't show up on the side where you would change the objects and everything else. So I was a bit confused on how to go about, writing everything out and graphing everything.
Fair
For
enough.
me as well. For me as well.
Okay. Yeah, it's a little bit some of them labs are a little bit glitchy and there is a bit of a learning curve. It's kind of like, basically there is a kind of an instruction page that we could go through, but I found that that's not as the best thing is maybe just to have this and we go through and kind of look at like as a in a Zoom meeting and just kind of play around with it and then to introduce you to that familiarity because it's kind of like with learning how to use Mac or a computer or something like that. You just kind of have to play around with it until you can maybe start to get used to it, and then ask questions if you have like you're doing now. So let's take a look. Okay, let's just introduce. So your hand's still up to Miko. You still got another question, or is that it?
Uh, no, that was it.
Okay. So let's take a look at this. So I'm going to first start here by zooming out, if just to give a perspective of what we're looking at here. So when we zoom out, we have this guy. Now you see this thing right here? This thing in the middle, this is like the classroom. And this is the bench right here that we were just looking at. And we were looking at it through what this is supposed to be as a camera right here. And so when you switch to that mode, you're looking straight down on the lab bench. Okay. So that's the perspective. Now with this thing, you can actually grab, this is the stock room. It's like a cabinet in the back of the class, and you could grab other objects and put them down. Like you basically put the cursor on it, press down, and just pull it off. Should be able to. Well, it kind of goes to mode where you can grab things and pull them off and put them down on the lab bench. Yeah, I have to admit it is glitchy. So, uh, yeah. So I'm grabbing a ball here, and I can put it down on the table. It should go down on the table. I have it access to this canvas. Let me try something real quick. Doesn't matter. All right, I'm gonna come back to you. So return items. Oh, so that worked. So these items were the items that were just down on the table. So if I go back to the table mode, which you can see from return to the lab bench, so that's lab. Okay. Um, okay. So these objects, I inadvertently returned them. So this is a ball, this is a plunger. All these things are down on the table. It's got this guy up here that I think that you're going to be able to use. I just kind of turned that back. So that's how it should have worked on the when I was in the lab bench. Like you grab on it, I can take it off the bench and put it up on the side of the table there. I guess just clicking it there, or I can grab it and pull it down. So, and I think even the way they sometimes they'll change the software from semester to semester, even how you kind of manage them. It used to be that you grab on everything. It looks like right now to put that back, I just clicked it and went back. But I remember having to grab it and put it back and bring it forth every time. Here, I'm clicking it down, grabbing on it, and dragging it to bring it out. Here, I just to put it back up there on the side, I just put the cursor on it, clicked it, and then went back. I don't remember that to be the case. I remember dragging back and forth each one. So little things like that. That's what I'm saying. You just kind of have to play around with it to see, if something is not working the way you think it should. But let's just go through all these the the different categories and things on the bench as well. So this guy over here is the lab book. If you click on that, it opens up, and as you do a lab, it puts your data in here for the different trials. So, for example, if I were to come back to the bench here and do a trial, and how do you do a trial? Well, you can have the plunger hit the ball and it should move. So, to turn on, a couple things before we do that. This is a recording device here that says recording. In order to make sure that you record data, you got to turn on the recorder before you start the experiment. This start button is the button for the experiment. This reset button is the reset button for the experiment. Now you could do the experiment without cutting on the data, and if you don't cutting on the recorder, and if you don't cut on the recorder, that information will not be recorded to the lab book. Okay. So I'm going to cut the recorder on. It says it's recording red when I'm doing that. Down here, you can see the data, like it's at zero velocity. It's set at 20 meters. So there's like this is kind of, I guess it's negative. Well, anyway, this is you can see the uh, kind of a coordinate system here and horizontally going, I guess if this is one, this is like zero. So this is kind of in the negative position, but it may have the positive axis turned around, whatever. But you can see that when we start the experiment, these parameters down here are going to change. So you can kind of maybe do it a couple times to get your bearings as to how it's set up. Let's just start. I press start. Now, we need to come over here and hit the plungers. Let me remember how to do this. So we can adjust the force here, but I think yeah. So you hit the force button to start it. And so as it was rolling along, uh, you see these parameters change. It rolled along with a certain constant velocity here, roll down to a certain distance, should be recorded there. And Yeah, just the various parameters that change. I'll get you in a second, Caitlin. Now, when I go back to this lab book, I should see some recorded data in that lab book. Well, it records it in that trial, but you have to open the trial. So if I open the trial, it shows all the data, and basically it's recording time and distance. So it started at yeah. So you see this first, you see how it's not changing up here going. So that was the time that I started the recorder and I was talking. So it just didn't move. So this basically this records time and distance, and that information you're going to take and manipulate, maybe graph or whatever in the first one or two questions of the worksheet. But you can see here, I started the recorder. It took me a while to remember how to hit the plunger. So while I was talking, it didn't go anywhere. The time was recording, but the ball was at the same X position that it, you know, of which I opened the experiment, which was 20 meters. So apparently, even though we kind of think of the left of the of the vertical axis as negative, that's just relative. You can set it up however you want. So apparently it's set up to positive 20. And so it was going back toward the y-axis, which is 0. And we're going to see here that once we get to where it's moving, the position is decreasing. So you see it starts to deep. So I basically hit the plunger at, I guess, 39 seconds in, after I was talking almost 40 seconds. And then the thing starts to move and it starts to decrease, goes back toward the origin, keeps going there and recording the time. And I'm assuming when it gets to 0, the ball disappeared. So it took 43 seconds to move from the left of the origin, called using that as positive distance, back to 0, and then the ball disappeared. So that was one trial. Okay, Caitlin, question.
Hi, yes, I actually do have a question about the labs. Does it also help us understand like the chapters as well?
It's supposed to, uh, supposed to, but not all the labs are necessarily coordinated with the particular material that you're doing that week, just because the physical science is kind of an overview course. So like just goes through a lot of things in one semester. But I will say that I don't assign any labs of material that we shouldn't have already have covered. So most of the labs here is going to be they'll be dealing with physical science. So like mechanics, velocity, force, things like that. Even though, and there are some thermal labs on it, but we go through we've already been through all the things I think they're going to talk about mechanics, and we're already into heat and thermodynamics. So most of the labs that you're going to be doing are going to be within the first few chapters, and ultimately there are some labs here for electricity and magnetism and some other things. But most of the stuff that we're going to be doing is going to be basically in the first 4 chapters of for the way I have it set up for the physical side. Does that answer your question?
Yes. Okay, thank you, Professor.
Sure, of course. Um, okay. Remember to take your hand down if you yeah. So that was trial 1. So I'm going to do another trial, then I'm going to open up for questions. So you have to reset it to get back to another trial. So just hit reset, and it should basically reset everything. And sure enough, it does. Now, I'm going to do one more trial, then I'm going to go show you how you should try it. You can change things, like change the ball, or change the force, or change whatever, blah, blah, blah. Right? Change the angle of which it shoots off. But yeah, and so when I reset, it'll reset all the parameters here, and when the ball disappeared, it also turned off the recording. Now this time I'm going to turn on the recording, and now that I remembered how to get the ball going, I'm going to immediately hit start, and then yeah. Or whatever. I don't know if it matters. I don't know why they have recording in the start, but I thought whatever. Can't remember the difference there, but I thought the start button should pop the ball off too. Anyway, whatever, I don't know. So recording, start, and then pause. Okay. Now everything stopped. Recording stopped. Experiment should have stopped. So now when we go to the lab book, we should see there's going to be another trial there, B2. Sure enough, now you see I haven't clicked on one. I'm going to close one down and then open two. And what we see here is that this might have been actually, this is the first one, I think. Oh no, this is this trial. So you can see that the period of recording is really small. It's like 0.1 seconds. So even though I hit it fairly quickly, I still got a lot of data there from where the ball was still. And why is that? Because it's making a recording every tenth of a second, every basically 0.128 seconds. So that's like a tenth of a second, approximately, less than a 20th of a second. So that's why it took almost 20 data points before I pressed the ball, even though I still pressed it pretty quickly. But still, it starts to record motion much quicker than previously. The last time I think it took 30 seconds or 40 seconds, something like that. Here it took 2 seconds. So after 2 seconds, I pressed and started the experiment, and the ball started to move. So that's how you read the data once you kind of get used to it. Excuse me. So the ball started to move, and it's still recording pretty much every tenth of a second. Look here, 2.627 and then 2.752. That's a little more than a tenth of a second. And it's showing the motion of the ball. And again, the ball goes all the way to through 20 meters down to 0. And it does that this time it does it in about 7 seconds, 7.39 seconds. And so every time you have a trial, it's going to record that trial here, and you can always go back and get the data. And I think it allows you to transfer the data. You say you can copy the data, you can transfer it to an Excel file. A lot of people do that so that they can graph it. You just copy that data and graph it in 2 columns and hit graph on Excel. It's going to graph it for you. Some people have figured out how to graph it on the worksheet because there's a little graphic there. You can do that. Some people have done that. Yeah, it just depends with that. But this is how to operate the lab and get the data for certain settings. Now let's go back and look at different settings. So that's what the parameters here over on the right. So when you open up that, it gives you a drop down menu. I'm going to go ahead and reset the experiment as well before we do that. So reset it here. Now let's look at the first parameters, objects. So the ball we're using is this guy, and I think there are other kinds of ball. This is a plastic ball, but when it asks you, it might ask you to change balls. So you do that, you go over here. It has just different types: plastic, steel, coconut. That look like no cement. Sorry, I can't read very well. Rubber. Let's just click to a rubber ball. See what happens. Well, I don't think it changes it here, but like the way it looks, but it has changed. Once you change that parameter, then the ball is changed. It used to be that you could have different balls. Maybe that's why I couldn't put the ball down, because it used to be that the balls up there actually look different and you drag them down. Looks like here, they're just, it's not changing the way the ball looks. I'm gonna scan out. I'm gonna change the ball to wood and just scan out real quick to make sure there's not nothing. They're not putting something up in like a new ball up in the stock room or something like that. Open up. That's how you scan out. You can still have the parameters over here. Yeah, it's not changing anything there. So I'm just assuming that the ball is wood. It still looks the same. But that's how you technically, if you change it here, it should be changed. I don't think there's a place where I have to save it. I think just clicking it there saves it. And yeah, I'm gonna go back to the table view. So you can just click on the table to do that. There's other ways to do it, which I tried to do before to exit the whole lab. But so zooming out gives you the whole overall lab bench. If I just click on the table here, it brings me back in. It zooms me back in to looking at it from the camera from the top. So diameter. So this changes the diameter of the ball. I think you got a couple settings here. You can go in here to this drop that way. Maybe no. So that looks like 3, and I guess this is 3. I'm sorry. I'm gonna have to. I can't see what the units are on that. Can someone tell? Is that meters? You see where my cursor is pointing? Does anyone see? So I'm at diameter. I'm going to change the diameter in a minute. It says 3, but so the mass is kilograms, but meters here, does it say 3 meters? Is that m, small m?
Yeah, it says 3 meters.
That's a little weird because that's a pretty big ball if it's 3 meters. Um, being a
That looks more
diameter
like it looks more like it could be like 10 or maybe 8 on the size.
or relative to the well, I don't know because yeah, I don't know. It looks smaller than that to me because I'm assuming that when you look at the vertical axis,
Mhm.
it says 1 and then 6 and then 9
Oh,
is
okay. I see what your point. Okay.
oh, but you know what? That's why it is 3. That's why I thought that was a 1. Okay, that's why it is 3. Because look, that's 3 meters, and if you look at the ball, you scroll over, that's about the height of the ball. So
Yeah,
that
they're
is
about
the
the same
diameter.
exact size.
Yeah. Yeah. So now, if I change this diameter, the ball should change. It should change its size. So let's see if it does. Yeah, sure enough, it does. That's high. So now that's up to 12 meters almost, or 12 something, it says. And sure enough, this is 15. So it's like 3. Actually, I think it changed the scale on the axis as well, because it was 3, 6, 9. Now it's 5, 10, 15. So the ball, you can see the height is somewhere between 10 and 15. So that's probably about, looks like it's about 12. And sure enough, it's saying that the diameter of the ball is 12.12, whatever. So that's how you change that. I'm going to go back to what it was. Oh, well, that's smaller than what it was. So they used to have I guess you can change it digitally. That's probably also easy to do because this thing is not very easy. It'd be hard for me to get it back to 3 exactly. So you could always, I think you could type in here. So I'm just going to type in uh, 3 meters to get it back to what the original was. And that should work. And then press enter. And sure enough, it does. Okay, so same with the mass. I'm just going to type in. I guess I could scroll back and forth. It looks like it's at 10 kilograms. That shouldn't change the size, but it would change the mass. So I could change it to. So originally it's 10 because I want to keep that original. So you put in 20 and press enter. The ball should change. One way, actually, let's do this to show that it's changed. I'm going to make it really large, like 50, and then I'm going to do an experiment again. And presumably, since I haven't changed the force on the ball, the motion of the ball to go across the screen should be longer because for the same force and a larger mass, you're not going to have the same basically initial acceleration, so it should be a slower constant velocity as it goes across. Now remember, when we looked at the table, it took for that second trial, it took seconds for it to go all the way across for 20 meters. When I change this to 50 kilograms and keep the force the same, presumably, when I do the same experiment, it should take much longer. Now it won't necessarily be a linear relationship. So if I change it 5 times 10 is 50. I'm not. Newton's law doesn't. Is it linear? I guess it won't necessarily work that way because it's not. But it should. So it's not necessarily going to be 35 seconds to get across. In this case, I don't think. But it should be longer. So let's do another experiment. So again, record and then start and then force. So record, start, force, and you can clearly see already that it is going slower, much slower. You can see along. You can look at here the time is recording the distance as it moves along, and yeah, Yeah. These other parameters are for like the vertical direction and things. So that's why. And this is momentum, I think, it's recording. We'll let it go all the way and then stop. Okay, good. Now let's go. That's the third trial. Let's go and take a look at that data and see what we got. I guess it opens up the third trial because this is the, where is it? Oh no, that's the first. So it records it on it. So I guess it automatically opens the first trial there. So we have to close that down and go to the third trial here. Yeah, this is the third trial. So we started moving, and then again, you can see it's still recording about a tenth of a second each time. But let's just scroll down and see how far, how long it took. The more data points, obviously, because it took longer. So whereas it took 7 seconds before, this time it took about 27 seconds to go through 20 meters. So once you take that data and start manipulating, you get a different constant velocity, you get a different whatever, a lot of things. But that's the data there for that. Okay, let's keep going. Let's change something else. So that's what else do they have here? So mass, I'm gonna change it back to 10. And well, the angle of the ball, here's where you can change that. It's at 0 angle, which means it's flat. If I change that to like 10 degrees, it should put it on a ramp. Or basically, it's going to change the direction in which the plunger is focused on the ball. So let's make it 20 degrees. I don't know why it's not changing it. I may have to scroll it in. That's interesting. It made the ball a ring instead of a uniformly mass distributed through. You could change that. Interesting. I think we may have to put this on a ramp first because it's not allowing me to change it. Maybe it's because you have to put the ramp down. So that's another place where it's kind of shaky. Like, you would think that they would have the software that if they have it there, you'd be able to manipulate it, would put the ramp on. But sometimes, like, it's not responding. So I think it may be that I might need to put the ramp on the thing before I change it. I'm not sure. But little things like that, you can when I first started doing this with this, like the first semester of quarantine, I think I actually had people go through there's somewhere on this software you can find like a kind of an introduction where it just kind of generically takes you through. But I kind of found that it was somewhat of a waste of time because you go through that and it's not specific to any lab. And then you come in and you kind of have to do what we're doing now anyway. So I just kind of and there's a couple pages that they have of introducing and explaining things verbally, and I just found it was a waste. I just think trial and error is the best. It usually requires like we have to kind of go through it in class at one. But once I kind of show students this and then you kind of play around, it kind of helps a little bit and you kind of figure out some things. But anyway, that's not working. So let's I'm gonna close that down and go to well, I guess we can keep it over. Let's go to ramp. Let's go to ramp here. Again, you can see it has an angle thing in there again. And let's see if that'll yeah, so now it is changing. Now I do believe that this is the angle at which it's moving, but this angle should have been the angle of the plunger. I'm not sure why. Somehow the plunger got put back up. You know what? Maybe that's what it is. I think maybe I inadvertently put the plunger back up there, and maybe that's why it wasn't working. Let's see if I can drag it back down here and put it on that guy. Let's go back here. Now the plunger is back on. Let's put in 20 again, see if it responds. Still not. Maybe because you know what? I'm gonna put my hand down here on the plunger and see if I can turn around. Now, if I turn this thing, I'm gonna see if the angle changes over here, which I think it might. I do not know what's going on with this plunger. It usually changes position. That might be a glitch, So it changes the other way, but it's not allowing me. I think I do remember this actually from a previous semester. I know that this thing used to change, but it's not changing right now for some reason, the angle. And I think that may be a glitch. Because you should be able to, like, if I put in 20 degrees, positive 20, the plunger would shift down so that it's going to shoot it up at an angle as opposed to, relative to the horizontal surface of the table as opposed to shooting it across the table. And it doesn't seem to be doing that. So, yeah, I think that's some sort of glitch somewhere. This just changes the units over here for these different things. We don't need to do that. Cartesian system. So you see the Cartesian system here. Looks like you can switch to polar coordinates, which it did there. I think that brought that up. So I'm just glitching here. So, yeah. Let me change that. That should be determined by the plunger. Apparently, it's letting me change it. I'm just going to play around with that. I'm going to make it 10 real quick and see what that does. Change it. All right, so record, test. That's a little weird. Change it, but that's position or not velocity. So why would it? Again, I don't know what's going on with that. So I changed it clearly says velocity, this is meters per second as the initial velocity, which, as I told you, that should be determined by the force of the plunger, not some just setting. But when I changed it, it changed the position from before it started. That doesn't make sense to me because this is saying velocity, not position. I could see if it said change the initial position, then I changed it. So again, the software that I'm guessing that that's some sort of software issue because that doesn't make sense. But we just have to work around these because this kind of thing because this is the best software out there that I know. And so we're gonna have, but I work with you on this. And once you get accustomed to it, you feel like you're not doing anything wrong. You can kind of sense where the glitchiness is happening or where it's not, or maybe something that you're just doing the wrong way. And it just takes a little while. There's a little bit of a learning curve. But now that you kind of see me doing it and you see these things happening, maybe you can start to be a little bit more comfortable with it. And anytime something pops up like that, it doesn't make sense, and you have to kind of work around something or fudge something in the data. Just send me an email, let me know. I can make a class because I'm still finding things actually in some as ouch. And I'll make a class announcement so that we can be aware of it. I'm going to go ahead and reset this. And I'm going to go back and reset this to 0 as well. All right, let's move on. So again, this is a ramp. You can put a ramp on it right now. It's on 0. You can put a ramp down to 20-degree and ramp angle. The length of the angle of the ramp can change. Okay, so like really long ramps, and then you have to take the ball and put it right back at the top. So you see how I just grabbed on the ball and put it back at the top because it changed the respective of the length of the guard. I'm gonna. It's a really long ramp. It's like 2,000 meters. I guess you can make it even longer. So the reason it looks like the ball is going down the ramp is because it's just changing, like you're zooming out, basically. That's what's happening here. But you see, that's a huge ramp, long ramp. And then, but I'm gonna take it back to zero where it was, and the angle. I don't know why the ball increased in size. Oh, because I guess it didn't. That's weird. Uh, Maybe it wasn't quite at zero initially. Remember what the initial value was. Definitely the angle was zero. Maybe the ball wasn't. Take this back to 10. Reset it because that just resets the experiment. Okay, well, I've changed it. I don't know how to get it back. I don't remember what it was, or angle was definitely zero. What is it? I guess it was 20. Yeah, it was at 20, wasn't it? Because okay, yeah, that's so it was at 20. That was 20 length. So that changes the length that it'll move along, and I'm gonna just take the ball back over. You can shift this along wherever you want, I guess. Really. All right. These are preset angles of the ramp. So once I was changing the angle as I went along, or the length of the ramp angle. Yeah. Or you could just click the ball and it will change it to whatever. Back and forth. All right. So close that out. Now, apparently the surface is frictionless, but you can change it, and you can do that a couple ways. The object would change the friction just by changing the ball. I changed it to wood. Again, you have all the same options there, wood through rubber. But you could also change the surface that it's sitting on. Right now, it's on a metallic surface. That's the surface of the table. But again, you got some of the same options there that you could change for the table. If I went to, I don't think it's going to change what it looks like, but it will definitely change the results you get once you home experiment. Tamiko, question.
Yes, for the assignment, it says changing the elasticity of the ball so that way it'll bounce, and I don't see that anywhere on the where we at right now. So that's where I was confused at.
Excellent question. That's a bit of kind of, I won't say miswording, but it's a way where they're using words synonymously. By changing the material of the ball, it automatically will change the elasticity. So, for example, just if it's a cement, if it's a steel ball, right, and you hit it, you throw it on the concrete, it's probably not going to bounce that much. It might even crack the concrete a little bit. But then if you change the ball to a rubber ball, clearly the ball will bounce more. So the elasticity has changed in doing so. Now, they should have probably been a little bit more explicit. And I think they used to actually have the for the material, it was like material slash elasticity, or they might have just had it as elasticity. That is actually something that they've changed since I believe since I've been using Beyond Labs. But I still use the same worksheets. Maybe on the newer worksheets they've made it more explicit, but the newer worksheets are a little bit more convoluted, and you can't download them. And they're trying to they're trying to force you to be able to go on to Beyond Labs. They're trying to force you to have to set up a class on Beyond Labs, basically, so that by doing that, they use it more and they show more usage, and I think probably even have you pay for stuff more. I don't know, but I just have the old worksheets, and so that is one thing that the old worksheets are written in such a way that there might be some things that don't seem quite consistent with the modified lab benches, and that's one of them. But just by changing the type of ball it is, it will change the elasticity. And so you can change it to rubber or whatever you want. Something that is probably, if it says greater elastic, just kind of try to use your intuition. Wood and rubber is going to be more elastic than steel and concrete of the ball. And just from your personal experience of however you might imagine. Um, but yeah, that is one thing that pops up, with this lab. So does that answer that question for you?
Yes, but also when I did that and it went just straight forward and then it like disappeared. So I don't know if I'm supposed to change the surface as well, or how do I go about that?
So what should happen when you change that? The data should actually change. So it's going to still be the same experiment, look the same way. But when you go into the lab book and you compare the data, for example, if it were rubber, it might take longer than if it were wood to get across, or if it were concrete, because it's basically going to be changing the frictional surface of the thing. The more friction, the better. The longer it's going to take, and so the experiment won't look any different. But when you observe the data, there should have been some changes there. And so it will end up having a different velocity and all that. But you're right, the experiment won't look much different if you didn't change anything else but the elasticity of the ball. Does that make sense?
Yes, and then I have so many questions. And then the next question I have is how do we for the worksheet, how are we supposed to graph it on there? Because there's 4 graphs and we're doing 4 different experiments. But the first question says the 2 lines. I was confused on how we go about doing the 2 lines on the graph.
Okay, so yeah. Excuse me. Let's take a look at that. And there is a way to do that. I think sometimes people like to use Excel and graph on something different. And you don't have to do it on the graph, it's kind of small, but people have been able to do it pretty. So let's see. I'll go back and take a look at that one. So I think with that, you might have to download the worksheet to your page and then um, convert it to something where you edit it. But let's um, we can come back. I mean, this is basically just going to be filling out, looking at forces and stuff. We can go back and do that. But I'm gonna, since you asked the question, I'm gonna go to that uh, worksheet and see if we can manipulate that a bit. So get back to that. That is. think I'm gonna have to download this. So what I have done here, I'm gonna just let me take a quick second. I need to go get some tea here. Okay. So, Miko, so your questions up, and Julia, yes?
Oh, I was gonna ask what software you're using because I saw that your screen pulled up the homework like that. So I was wondering how are you able to do that? Because I couldn't do it.
Okay, I see. Well, this is just I think this is Adobe.
Adobe?
Uh, yeah, like it makes it basically when when I download this, it makes it a PDF. So this is
Okay,
just the standard PDF stuff. I don't know. I don't think I even paid for it. It's just yeah.
okay, because I couldn't type anything on my end because we both have the same exact computer. I'm not able to like type or write anything on that PDF file, so that's a pretty good question.
I see, huh?
Yeah,
When you say we
I
have the
had
same
to.
computer, you mean you and Tamiko, or you and myself?
Yeah, you and I have the same exact computer, so that's why I was wondering like how can I be able to like write onto that PDF file because the other night I had to print the homework out and I had to send pictures that way to turn it in. So,
When you're talking about the homework, you're talking about the lab or the actual
the
homework.
actual homework.
Oh, that shouldn't be the case.
Yeah.
Definitely with the homework, you have Wally Plus, right? You should just be able to. So we have to address that because the homework, that's you shouldn't have to do a PDF for the homework.
Yeah.
So let me handle this with Tamika and then see if we can go back to that real quick.
Okay.
So I think that with this, and there may not be a way around this because just uh, whatever generic PDF reader you can have, I think um, you, because I don't remember paying for this. Right? It just sometimes I don't know. Isn't this is not the same as this is something actually that kind of looks new. I thought it maybe just upgraded whatever Adobe stuff I
Uh-huh.
had. I'm not sure, but this is what it would download to, and then I think I can, the text box on. You can write on that and do stuff there, type in, yeah. So I think you can see it there, like just by hitting the text. So that's how I'm doing that here, and also, but it's not really for the graphing. I don't. You can use I probably would use Excel um,
Okay.
because you can just download that data to Excel and then you can just upload the Excel graph. You don't have to even put it on here. You can just answer the questions here and then upload that and then put another page for Excel. A lot of students just do that. But
Okay.
I do know some students actually do draw on this thing and it make it. So I think if I've never really tried to do that, but I think if I
Uh-huh.
took this one of these markers here, maybe took that, it might draw it. Yeah, so they'll draw a line on there. So what you'd have to do is literally like draw out, like put an axis, like maybe make the thing black. So then I could put an axis here and then here, and I don't know how you make it a straight edge. Maybe you can, I don't know, and then number it or something like that, or just put the numbers on. Maybe you could expand this page so that you can write a little bit, write on it better. I think I can expand it. Where is it? Like here, zoom in or zoom out, so I can zoom out a bit more. Yeah. So as opposed to because that's kind of messy drawing. What if I zoom out enough, I could just like label every second or third. Yeah, something like that. So now here I'm gonna see if I can erase. I've already kind of messed this up, but I could go back and erase these lines. So then I would just put like the y-axis, whatever it is, if it's in meters and the x-axis in seconds, we'll label this 2, 4, 6, 8 meters or whatever, and then 1, 2, 3, 4. But here you're gonna have to draw in the lines. Whereas with Excel, it'll literally graph it for you. So Tamiko, do you have? I'm assuming you have access to some Excel somehow on your either. Do you have a PC or a Mac?
I have a Mac, but I have access to Excel.
Yeah, I would do that. What I would do is, as opposed, because this, you have to draw it on. It's just like drawing it with your crayon, with a pencil or something. So you have to scale it. But with Excel, it's all you just copy that data, and I showed you when we have to go back to it. But when you're in the data book, when you press copy, it copies the data in whatever they call it, memory thing in your computer, and then you go to Excel, and it will paste it into the column. And then once you have or you could just manually do it, but I think copying and pasting is better. And then you go to linear graph, because it would be a linear graph on Excel, and just hit the button and it graphs it. Gives you the slope, the y-intercept, graphs the picture. Then I believe there's a way to copy that picture, and then you could just or either download it as a separate page digitally, and then you can just upload that page as your graph as a separate page into the module for the for the thing. Or
Oh,
there might be a way to paste that picture onto this graph too. I don't know if you do all that, but whatever.
I
Yeah, go
did
ahead.
what you just uploaded right now. I
Yeah,
just uploaded Adobe and it seems like it's free.
yeah.
So I have it handled now. Thank you so much.
Yeah, no problem, no problem. Yeah, I apologize. I think that I did this years ago because I didn't remember paying for it. So I think there's a free version of Adobe where you could just do this.
Yeah,
There's
this is so helpful. Thank you so much. Like I I should not have even like printed the homework the other night, so now I get
yeah,
it.
yeah, no worries. Yeah, like I see here in the up left-hand screen, it says upgrade to Pro. Pro probably will have you be able to draw straight line. I don't know what it does. I don't do that, so I don't use that. So Uh, so you should be able to download those sheets to Adobe here, and then just to type on it. You choose, I think, the text box. Then you type on it here, and then you can just answer the questions like that. But as far as the
Okay.
graphing, that is a little bit more tricky. But I would suggest D'Amico, I would try what I suggested. But I do know students have figured out how to actually go in and make straight lines and all that on the page like I'm doing here. I have to spend a little bit more time doing that to figure out how to make them straight. I think there's a way to do that, but it's specific to the data. So I think they might have been somehow taking the Excel and then pasting it onto this thing, or you could just upload the Excel as well. I would just use Excel, as opposed to trying to manually graph it on this page without some other software assistance, if that makes sense.
Okay. And I have another question. Can we get
Yeah,
an extension for this assignment? Because I've contacted almost everybody in the class and they were just as confused as I was. So I,
absolutely. Yeah,
okay, thank you.
yeah, yeah. I will do that. Can you, Tamiko, just to remind me of specifically, can you write me an email saying specifically what I think it's probably already in emails. Some of them I haven't looked at, but just send me another email right now, if you will, just so it's a mental note when I go through and actually I will remember that I need to address this as a class and not specifically for individuals. Um,
Okay. If you
Thank you
want me to
for
do it
that,
through Canvas,
Professor.
yeah, always use the Canvas. Don't use the office email now that we have the class open. Because
okay.
I have actually notifications from the Canvas coming to my phone, so I always know when emails are coming in or when I'm getting behind. But with the office email, that's not the case, and so I don't necessarily check it every day once class starts. The office email, that is. So
Okay.
always use Canvas from here on out. Okay.
Okay, thank you.
Yeah, sure. Did someone else about to say something or was saying something?
Oh, I said thank you for that because I needed some more time on that too.
Oh yeah, absolutely. Anytime. I'm pretty lenient with time. So just whenever you need some more time on something, just send me an email, and I usually try to get it before the deadline. If not, I'll even, to an extent after the deadline. All right. So let me get this tea. When we come back, I'm going to go back to the lab and finish up. Actually, before we do that, I was concerned. Was it Julia about like there shouldn't have been an issue with having to download the homework. So I'm going to make sure I understand what's going on with that. Can you? Was that Julia? Was that you that had the issue?
Yeah, but since you kind of explained it because you did mention the Adobe, I just now downloaded it, so I don't think I have that issue anymore.
But again, with the homework, you shouldn't need to do Adobe with the homework. There's when you meant
Right.
homework, were you talking about the labs or were you talking about the actual physical science homework in the physical science modules?
It was for the lab.
Oh,
It was
okay,
for the
okay.
lab, yeah.
Yeah, so that's it. So, yeah, so the modules for the class homework that's Word Wiley Plus. That has nothing to do. You don't need Adobe for that. But yeah, okay. Well, yeah, graphing homework. Yes,
Yeah.
that's the thing. Okay. All right. Cool. Let me get this tea, and we come back. Let's go back to. I'll share my page again with Beyond Labs, and then we'll go through the rest of those uh, parameter options. Okay, well, that's back again. I was trying to get it to, I was wondering why I didn't fill up the whole screen, but I guess you can adjust that on your end. But I guess you can see that now. So, yeah, here, I think this is starting to become hopefully a bit more clear. So that's friction. So, yeah, it just changes. Now, the friction coefficient, that's something that you can change as well. It just, I don't think it's going to have you change that in the manual. That's for the more advanced, probably calculus-based stuff. So just changing I think we were talking to Miko, just changing the elasticity will probably change the friction. And that's probably how they have you doing it. And you just change the ball, just change the substance of the ball. And you can change surface too, but I don't think I'm not going to mess around with the coefficient because I don't think they're going to have to change that. Although it's really just a matter of clicking on it and changing the number. Just leave it as it is. Okay. And then here's the forces. Here's something that is a little bit more dynamic, and we can change that. So I don't know what it's set at here. It looks like again my eyesight is a little bit off. Is that 900 newtons? N represents Newton, so I think that's 900. And this is angle is 360. Maybe that'll change the angle of the projection. I was trying to do that a while back. Try it. Let me change it. Change here, scroll through. Yeah, I think this is the glitch. It used to be that you could change the angle. Maybe I need to go to a different. Yeah, I think on this one it's not letting you change the angle. It may be because this is physical science. That might be what it is. I think I figured that out. Yeah. I think they don't on this lab they don't have you change the angle. That's why you can't change it here. Remember, I told you that the worksheet is set up for that specific lab. So, for example, if we went to physics or higher education for physics, 'cause this was a high school, I think, physical science, the motion lab would look very similar, but on that you would be able to change the angle. That's probably what's going on because I don't think that they have you change the angle within the worksheet. So because this lab is set up specific to that worksheet, some of the parameters here don't work because they're not going to require you to do that or at least do it that way within the labs. I think that's what it is. So the magnitude of the force that will definitely change. I'm pretty sure. Um, yeah. So with a higher force, so that was at 900. With a higher force, it should be that the ball is going to go off faster. So let's just do it. Well, we know what this trial is. At 900 is doing what it does, and let's just take a look at that again just to make sure for our memory. So, and I've changed the ball back to 10 meters. So this should be about 7 seconds to get across, like it was in our initial trial. If I go down to that trial and take a look, we'll scroll all the way down and we should see that it's 7 seconds. Well, it's 5 seconds there, maybe. I don't know. So that's another thing. Sometimes this is supposed to be real data. So even though I've gone back to the original 10 meters or 10 kilograms, oh, but maybe the initial position might have been changed a little bit. I didn't take a look at that. Let me reset because remember I was changing yeah, it's at 17 meters. Remember it was initially at 10 meters. So whenever I was changing the ramp and stuff and I was moving the ball back and forth, I didn't specifically put it at 20 meters. But I think I can go in here and actually change this to 20 somehow. Well, I might have to go back to the initial position. I'm not sure where that is. Objects. It was it should have been at that velocity, but that ramp, it's saying initial velocity, but it looked like that changed the position. I don't know. It looks like, I mean, definitely I can change it by moving it along here, but there should be a place where you can be a bit more specific. But if I move this back, what that is? Oh, that's it, 20 meters. So if I so I was able to do it just by shifting it like that. I might have to change the scaling because remember with the scaling before somehow I could see the plunger. That's down here. Scaling is here. Um, Maybe it's a zoom out. I don't know how that changed. Auto scaling, fixed scaling. Hmm. That's the change. I don't want to leave that. Zoom out. In and out. Minus 20 plus 20. I don't know. Like, I guess what I'm trying to say is I know we were at 20 meters before, and this bar, like, I could see all of the plunger now. And so it's basically the coordinate system that's kind of changed, and I'm not sure what I did to change that. It happened whenever I was doing the making the ramp bigger and smaller. That's not such a big deal. I mean, I could figure out at some point, but I'm just going to go ahead and do the trial. I can't quite remember what's able to see that. Anyway, I'm gonna go ahead and do the trial, and right now I'm gonna change the force to, let's do it by that's 900 thousand. Let's do like 3,000. Change it by almost a factor of three. Okay, just type it in. 3,000. Okay, so now I'm gonna do a trial. It should go faster. Now remember with the 900, actually, you know what? Let me go back and do the 900 because that now that I have that 20, I think I remember that to be about 20 seconds for this particular force. So 900, that's the original force. Let's do a trial test and go. Reset that. Go up, take a look at the data. Go down here, and sure enough, well, still about 5 seconds. I don't know why. I think I was anticipating more like 10 or 7 or so, but okay, it is what it is. All right. But that trial gave about the same. It's not quite, it's not going to be quite the same because realistically, it's trying to mimic actually real data, like what you would do in the classroom. So there might be some changes, even if you try to set up exactly the same. You know, it's human error. It's different. You know, things are. It's not that this data wouldn't actually be that specific. It would change slightly. So it's trying to mimic real circumstances, even though you tried to set up exactly the same. So just keep that in mind.